In this video, we are going to find the minimum number of chairs required for seating. Hello, this is Jagan from growwithdata. I am posting this video to share my knowledge in Python language with you. If this assists you in your interview preparation in any ways, I will be happy. Welcome to the 90th video of the Python interview question series. I have created a playlist Python interview questions 51 to 100 and I will be tagging this video to that playlist. The code we discuss in this video will be posted on the GitHub and the link will be provided in the video description. Now let's see the sample input data and we can talk about the question in detail. So we are given a string yes. It has the seating arrangements. E means a person coming to the waiting room and he takes out the chair. He sits in the chair. L means the person, he leaves the room. So the chair will be free. So we are simulating that event based on the string. So now we have to find the minimum number of chairs needed so that the chair is available for every person who enters into the waiting room, given that initially all the chairs are free. If you see this data, I'm going to break down into each step. So first is E, L, E, L, L, and L. So initially E means somebody comes and occupies the chair. So he needs the chair 1. And then he leaves the place. So it's 0. Right? No more chairs. Everything is empty. Then some other person comes, he occupies the chair. The second person comes, he needs the second chair. Right? Okay. And then one of the persons leave. So only one chair is needed, other chair is empty. Then a person comes. So already there is one chair and then he adds up to the second chair. And then another person comes, he needs the third chair. After that, nobody comes, everybody is leaving. So only 2 chairs required and 1 chair is required. At end, no chairs are required. So when you see this, first we need 1 chair and then we got 1 and 2 chairs, then 2, 3 chairs. So the maximum when they came inside and they left, maximum chair required was 3. There is no need for more than 3 chairs. If there is 4 or 5 chairs, it's going to be empty again. So the answer is going to be 3. So if we have 3 chairs, that means nobody is going to stand. Whenever persons come and they leave the waiting room, they will have at least 1 chair, provided the sequence is having only the max of 3. If you try some other sequence, for example, I say yes is going to have all the persons coming and getting the seat. Let's break down and see how many chairs they need. So here first a person comes and he gets a chair. Second also he gets a chair. Nobody leaves. Every person is coming inside and they started getting a chair. So let's see how many chairs are required for this input. So we got 7 chairs. So whoever came into the waiting room, nobody left. So at the end of the day, if you have 7 chairs, then nobody is going to stand. Everybody will get a seat and they are happy. If you see another example, right? Let's go with another third example. Here we have a pattern of E, L, right? So here first one person comes and he gets the chair. So we need 1. And then that person leaves. So all the seats are empty. Another person comes, he also leaves, so it becomes 0. Then one person comes and then another person comes. So we need 2 chairs to accommodate till now. And then one person left, so we have only 1 seat is occupied. So if you have 2 chairs, then this sequence will make sure that all the person are having a chair to sit. So this is what they are trying to ask. So what should be the minimum number of chairs we need to put in the hall? So when the people came into the room, they should have chair to sit. So that's what we are going to convert that to a program. So let's start with our basic looping logic, right? Let's go with that. So we have the string here. I'm going to define the function def growwithdata. The input is yes. I'm going to create two variables. One is count, another one is the maximum count. So whenever there is a person who comes and sit, then we are adding a chair, right? So at any moment we have to check what is the minimum number of chairs required, so that even the traffic is at the peak, right? So maximum people comes in and sit, we have to provide the minimum number of chairs so nobody stands. The minimum number of chairs are supporting the maximum number of visitors, we can say that way, right? Okay, so we got two variables. Now I am going to read each element in the input string. I say if the element is equal to e, that means somebody is taking the chair, right? So the count is going to be equal to 1. So we increment the count. If somebody leaves, right, we have e and l, so the count is going to be -1. That means we are freeing up the chair. So when somebody comes, we add the count. If somebody leaves, then we just subtract. Now once the sequence is done, like one element is done, we just say if the count we calculated, right, is greater than the max count, then the current max count is going to be plus equal to, sorry, maximum would be equal to count. So if we add the count, increment the count by 1 if you find the e, right? So we every time we check if that incremented count is going to be maximum greater than the maximum count we till now we calculated, right? And we replace it. Now we return maximum count. If you call the function, let's see what happens. Maximum count, spelling mistake. So we got a minimum of 3 chairs to support the maximum person coming into the room. Let's see how this works. So we initialize two variables. Now we are getting the sequence. So the first is going to be e. We are checking if the element is e. Yes. So we just say count equal to 1. This is a 0, so it becomes 1. There is no else statement. Now we are checking if the count is greater than maximum count. Now count is 1 is greater than maximum count is 0. Yes. So we come here and we just say, hey, now the maximum count is going to be 1. Now we go to the next one, which is L. So it's equal to E? No, it comes to the L statement. So L statement, we just decrement the count. Count equal to 0 now. Now all the chairs are empty. So here we are checking if the count is greater than maximum count. Maximum count is 1. Now the current count is 0. So we say no. Now we go to the next one. Next is going to be E. So you check if I equal to E. Yes, it's equal to E. So we do the count increment. So count is currently it's 0, right? Just say count. So count is going to be 0. Now we are adding up 1. So count equal to 1. Else we ignore and we check if count is greater than maximum count. Count is 1. Maximum count is also 1. So it's not greater than. So we just ignore it. We come here next. The next one is E again. So is it E? Yes, it is. So you increment the count by 1. So count equal to 2 now. Else is ignored. Now we check if the count is greater than maximum count. That is 2 is greater than 1. Yes, of course. So we make the maximum count as 2. Maximum count equal to 2. Again we go with L, that means we decrement it, and then we go with E and E. So whenever the maximum count is getting tracked, we make sure that the next iteration the count is incremented, and we check if the count can be greater than whatever the maximum count we calculated now. Based on that, we just return the value. So for this example, we can't do much, right? So this is the max we can do. If you want to try for few test cases, then you can use the growwithdata with asset function. So here we have 3. So here's this one will be 1, and then this will be subtracted, and then 2 and 3. Here we saw it's 7, and this one is 2. We tried all this here, how it works, right? So since this code is having the scope is like very less. We have for loop and if condition. We can't do much, right? We can try a few options, but this is the easier way to do it. So instead of giving a raw code like this, let's see how to improvise the code. A small tweak is going to show some good features in the code. Let's see what we can do. Here we do the if condition, right? If the count is max blah blah blah. So instead of that, I can simply say the max count equal to the maximum of the max count and the count we do every time, right? So this will cut down the if condition in 2 lines to 1 line of code, maximum count. Next is this if condition. If I equal to E, then this, right? So if we say count equal to count plus 1 if I equal to E, else they say minus 1, right? So the complete if condition, the 4 lines of code, right? We just made that as a single line, and that works. Now we assign the variable 2 lines, right? So instead of that, we can just say maximum count on the count in single line. So we just do it here. Even then we can use the for loop here and create a list. Even we can do that, but the looping is okay. We just do 2 lines of code, so that will be much appreciated. If you want to practice the code, you can just go to growwithdata YouTube channel. The playlist is going to be in Python interview questions 51 to 100. The Tamil version also, Tamil Python interview questions 51 to 100. If you go to the playlist, you have all the videos related to that playlist, and in the description part you will have a GitHub link. It will take you to the code base. So whichever the code related to that video, you will just see this. The one we are talking about now is the 90th video, so that will have the code we discussed here, the normal for loop, and then how we fine tune that and make it into a 4 lines of code. Now I hope you like this video. Thanks for watching.